Hello everyone. Today we're going to look at how to factor polynomials. Before we factor, let's go ahead and review a couple of things. First, we have this graph of f of x, and we want to write out all of these qualities of this particular function. So first, we're going to see if we can determine what the domain is, keeping in mind that the domain is the set of all of your x's. And for domain and range, we're going to use interval notation. Now, as you can see that this graph is going to open forever to the left and it's going to open forever to the right. There are no breaks in between. Therefore, the domain is negative infinity to infinity. The range is the set of all of your y's. So we look at the smallest y value to the largest y value. You can see that the smallest y value is here at -4. Because this is a solid curve, that means that the -4 would be included. So we would use a bracket. Then the rest of the graph goes up towards infinity. So we would write infinity. Now we're going to look at the extrema, which is just another word for maximums and minimums. We have relative maximums and minimums and absolute. Relative is like second place. It's a maximum, but it's not the absolute maximum, meaning that it's a little hill, but it's not the highest hill. So for the relative maximum, we can see that it occurs right here at this coordinate, which is at 2, 0. Now that's relative because the function does have values above it. Even though it is the highest hill, since the graph goes up forever, it cannot be an absolute because there's more behavior on top. Now the relative minimum would be a little dip, but not the lowest dip. So that would occur right here at at +4, -1. Now, if we wanted to find an absolute maximum, remember that maximums and minimums are coordinates. They have to be coordinates. It has to be a real number. But since this graph goes up forever, that means that it's going towards infinity. There is no absolute maximum because I cannot put a point on infinity. Now, the absolute minimum is the lowest dip possible, which is right here. And that looks like it's right in between -2 and -1. So we would say -1.5, -4. The y-intercept is where the graph touches the y-axis, which is here at 0, -2. Or you can say y is equal to -2. The roots are the x-intercepts. So we're going to look at where the graph touches the x-axis, which is here at the 2 and 5. So we can write them as coordinates, or you can write that the roots are -3, 2, and 5. Now, what can you tell me about the multiplicity of each root? Remembering that if there is an odd multiplicity, the graph will cross the x-axis. And if there's an even multiplicity, it will only touch the x-axis. So we can see that at -3 and 5, it does cross the x-axis. So we would say that at x is equal to -3 and 5, it has an odd multiplicity. At x is equal to 2, however, you see how it only touches the x-axis and then goes back in the same direction. So this would have an even multiplicity. Now we're going to write the polynomial in factored form. Factored form means all of those individual parentheses. So we would write f of x is going to equal, now in factored form, that's based on the roots. Since when we're trying to solve a polynomial, what do? We make it equal to 0, we factor it, and set each factor equal to 0. So we're going to look at our roots here. If x is equal to -3, in order to get the factor, we would add the 3 over so that we make this equal to 0. So x plus 3 is equal to 0. That's one of my factors. Since we said that at -3 there is an odd multiplicity, we're just going to leave it with an exponent of 1. So we're going to write this polynomial with the least degree. Now for x is equal to 2, In order to make this equal to 0, we would have to subtract the 2 to both sides. So x minus 2 is equal to 0. That would be my factor. Now, keeping in mind that we said that here it has an even multiplicity, I'm going to raise it to the exponent of 2. And finally, for x is equal to 5, in order to make this equal to 0, I would have to subtract the 5. So x minus 5 is equal to 0. And that would be my last factor. Again, this has an odd multiplicity, so I'm just going to leave it with an exponent of 1. Now let's look at how to solve polynomials using factors. Because that's basically what we're going to do today, is we're going to learn how to solve polynomials, but we're going to have to factor it first. But just in case, right, just so that we understand what to do with those factors, in order to solve, remember that we're going to use the zero product property. And that means that you take each individual factor, so 2x, we make it equal to 0. And x minus 1 equals to 0, and 2x plus 3 is equal to 0. And then in order to solve, we would need to solve for x. So in this factor, we would divide the 2, and 0 divided by anything is still 0. Here we would have to add the 1, so x is equal to 1. And then here I would have to subtract the 3, so 2x is equal to negative 3, and then divide the 2. So x is also equal to negative 3 over 2. And these would be my 3 solutions. Now, the number of factors that you have that contain x, that's going to tell us how many answers we have. We have 3 factors with x, therefore I should have 3 solutions. For this next one, we have negative 3 times 5x plus 2 times x minus 4. Remember that we are going to only take the factors that contain x and make it equal to 0. This negative 3 is not going to affect our answers. So we just kind of ignore it when we're solving. We're only taking the factors that have an x. So 5x plus 2 is equal to 0, and x minus 4 is equal to 0. For this first factor, we would subtract the 2. So 5x is equal to negative 2. And then we would divide the 5. So x is equal to negative 2 over 5. For this last factor, we would have to add the 4. So x would equal to 4. And see, again, I have 2 factors that contain x, therefore I should have 2 answers. Now, if your polynomial is not in factored form, as you can see here, this is not factored because I don't have those individual parentheses, we will first need to make the equation equal to 0, make sure that it is in standard form first, and then we would factor. So let's try that out. I'm going to add the 2x to the third over to the other side, so that way it equals to 0. And I get the equation in standard form would be 2x to the third minus 22x squared plus 60x. Remembering that standard form is when you have all of the individual terms with the highest exponent first. Once you're here, we're going to look at every individual term and see what they all have in common. As you can see, every number is divisible by 2, so I'm going to factor out a 2. They all have at least one x, so I'm also going to factor out an x. Now let's see what I get when I take out the 2x. This, remember that when we're factoring something out, that's basically dividing it from each term. So 2x to the third divided by 2x is x squared. 22 divided by 2 is 11. I already took out an x, so there's only one left. Plus, and then 60x divided by 2x would be 30. Now we have to think of what two numbers multiply to give me positive 30, but add to give me negative 11 since this is a quadratic. So we have 2x. We're going to open these two parentheses. The two numbers that multiply to give me 30 and add to give me negative 11 are negative 6 and negative 5. So we would write it as factors x minus 6, x minus 5. And now this is in factored form. Once it's factored, you take each individual factor and you make it equal to 0. And now we solve for x for each one. Here we would have to divide the 2, and 0 divided by anything is 0. Here we would have to add the 6, so x is equal to 6. And here we would have to add the 5, so x is also equal to 5. So our three answers here are 0, 6, and 5. Also remember that the highest exponent tells us exactly how many roots we're going to have. Roots is just another name for the 0. Since we have an exponent of 3, that means that we should have 3 answers. Let's try this one. We have 3x to the third plus 4x is equal to negative 7x squared. So first I'm going to have to add the 7x squared so that my equation is equal to 0. And now I'm going to write this out in standard form. So 3x to the third plus 7x squared plus 4x is equal to 0. Then I'm going to see, is there anything that I can take out from every term? All of the numbers are not divisible by the same number, so I can't factor out a number, but they all have at least one x. So I'm going to factor out an x. And that would leave me with 3x squared plus 7x plus 4. Now we have another quadratic. The problem here is that we have a number in front of the x squared. So this is where we're going to have to use the AC method. And we're only using it for this. So I don't want to forget about my x here. So even though I'm going to be working with this quadratic here, I'm still going to write down the x on the outside so I don't forget that we have that there. So remembering for AC method, you have to first figure out what is A times C. 3 times 4 is 12. And now we have to think of what two numbers multiply to give us 12, but add to give me 7. And those numbers would be 4 and 3. So now I'm going to rewrite this quadratic, replacing 7x with the 4 and the 3. So we have 3x squared plus 4x plus 3x plus 4. See how I replaced the 7x with the 4x and 3x. And now we factor by grouping. So we have this x here. I'm going to open a bracket so I can keep myself nice and organized. 3x squared plus 4x both have an x in common. And when I take out the x from those two terms, I'm left with 3x plus 4. Now in this next grouping, they have nothing in common. So when that happens, you just write plus 1. And then we have 3x plus 4. So now our factors, we have this x on the outside. We have the 3x plus 4. Remember that the one that is the same inside the parentheses, that's one of your factors. And then what's left over is your other factor, so x plus 1. Now we have to set each individual factor equal to 0. So this is factored form. So we're going to make x equal to 0, 3x plus 4 equal to 0, and x plus 1 equal to 0. Now for this first factor, there's nothing to solve, so x is equal to 0 is one of my answers. For this next one here, I would have to subtract the 4 first, so 3x is equal to negative 4, and then we would divide the 3, so x is equal to negative 4 over 3 is another answer. And for this last one, we would have to subtract the 1, so x is equal to negative 1. And that's how you would solve polynomials once you have it in factored form. For now, what I want to do is try this a little bit more. And then we're going to get into more factoring problems. So we have here 6x to the third plus 3x to the fourth plus 72x squared. So first we're going to have to subtract the 72x squared so that this equation is equal to 0. And now we're going to rewrite this in standard form. So my highest exponent is the fourth, so 3x to the fourth plus 6x to the third minus 72x squared. And we make this equal to 0. Now each individual term can be divided by 3, so I'm going to factor out a 3. And then they all have at least an x squared. So I am factoring out the 3x squared. And now what I have left is x squared plus 2x minus 24. So I even have it here in blue that the trick is to factor out the greatest common monomial first, also called the greatest common factor, which in this case was the 3x squared. And then we factor the quadratic that we have left inside of that parentheses. Here we have no number in front of the x squared, so we can actually factor this by trying to find the two numbers that multiply to give us negative 24 and positive 2. The two numbers that multiply to give us negative 24 would be 6 and negative 4. Since 6 times negative 4 is negative 24, and 6 minus 4 is that positive 2. So my factors are x plus 6, x minus 4. So this is my factored form. Now I take each individual factor and we make it equal to 0. For this first factor, we have to divide the 3. 0 divided by anything is still 0. So x squared is equal to 0. And even if you square root both sides, x is still 0. So this is one of my solutions. For this next one, we would have to subtract the 6. So x is equal to negative 6. And for this last one, we would have to add the 4. So x would equal to positive 4. Let's look at this last one here. We have negative 6x is equal to 15x squared plus 6x to the third. So you can either choose to subtract everything over to the left, but we only have one term here, so I would rather just add the 6x over. And that way my equation is equal to 0, and now I'm going to write this out in standard form. So we have 6x to the third will come first, plus 15x squared plus 6x. Now let's factor out the greatest common factor first. Each one of these terms can be divisible by 3 as well, and they all have an x. So I'm going to factor out a 3x, and that would leave me with 2x squared plus 5x plus 2. Now if you notice inside here the quadratic, we have a number in front of the x squared. And not all of these numbers are divisible by 2. So we're going to have to use the AC method for this. So in this case, AC, 2 times 2 is 4. And the two numbers that multiply to give me 4, but add to give me 5, are 4 and 1. So now I'm going to replace this 5x with 4x plus x. So remember, I don't want to forget about this factor, so I'm still going to write it down here. And now I'm just going to open a brace, so that way when I write extra parentheses, it's not like a jumble of parentheses. So we have 2x squared plus 4x plus 1x, which is just x, plus 2. And now we factor by grouping. So again, we have this 3x on the outside. 2x squared plus 4x both have a 2x in common. And that would leave me with x plus 2. X plus 2 does not have anything in common, so we just write plus 1 and then copy that factor inside of the parentheses. So now what are our factors? We have the 3x on the outside. What repeats here in the parentheses is our second factor. And then what's left over is our last factor. Remember that it does not matter the order in which you write your factors. That's just the way that I do it. So here we go. These are all of our factors. This is factored form. So now we're going to take each individual factor and set it equal to 0. So 3x equals to 0, x plus 2 is equal to 0, and 2x plus 1 is equal to 0. Here we would have to divide the 3. So x is equal to 0 anyway, because 0 divided by anything is 3. Here we would subtract the 2, so x is equal to negative 2. And in this last one, I'm going to subtract the 1, so 2x is equal to negative 1, and then divide both sides by 2. So x is equal to negative 1 over 2. Now, in order to continue with these kinds of problems, we're going to look at some special factoring, meaning that there are sometimes some factoring techniques that we can apply depending on patterns that we see. So first, we're going to look at a difference of squares. Now, a difference of squares is exactly what it sounds like. It's a difference, so that means that you have subtraction, and you're subtracting two terms that are both perfect squares. So that's how you recognize a difference of squares. Two terms only, subtraction, both of which are perfect squares. A perfect square is basically a number or a variable that can easily be square rooted, meaning that 25, for example, is a perfect square because you can square root 25 and get 5. X squared is a perfect square because you can square root x squared and you get x. So let's look at this example, which is exactly what I was talking about. X squared minus 25. It's a difference of two perfect squares. So what we do is we take x squared and we square root it. This cancels with this and we're left with x. And then we get 25 and we square root it, and the square root of 25 is 5. So our factors would be x plus 5, x minus 5. Since remember, when you square root a number, it's always plus or minus. So positive 5, negative 5, and that's it. In this next example, we have 36x squared minus 49. Again, this is a perfect square, this is a perfect square. If you square root 36x squared, the square root of 36 is 6, and the square root of x squared is x. The square root of 49 is 7. So now we just write our two factors making one plus and one minus. So 6x plus 7 and 6x minus 7. For 9x to the 4th minus 16, this is how this works, okay? If you square root 9x to the 4th, I'm going to break it down so you can see exactly why this is what it is. 9 is 3 and 3, right? So that's going to go outside. X to the 4th means that we have 4 x's. So we have two pairs here. So remember, if you're taking out multiple terms out of a square root, you multiply them. So this is an x times another x, which gives me x squared. So that is my first term, 3x squared. Then the square root of 16 is 4. So my factors would be 3x squared plus 4 and 3x squared minus 4. Here we have 4x squared minus 81y squared. If I square root 4x squared, the square root of 4 is 2 and the square root of x squared is x. The square root of 81y squared is the square root of 81, which is 9, and the square root of y squared is y. So my factors here would be 2x plus 9y times 2x minus 9y. So that is a difference of squares. Now we're going to look at a sum or difference of perfect cubes. A perfect cube is any number, just like a perfect square is any number that can be easily square rooted. A perfect cube is any number that can easily be cube rooted, meaning that you need 3 identical numbers that give you the number that is a perfect cube. So for example, 8 is a perfect cube because if I cube root it, you get 2. The only other ones that I will be using, or as high as I would go, would be, for example, the cube root of 27. That would be 3, because 3 times 3 times 3 is 27. Then let's say the cube root of 64. 64 is also a perfect cube because 4 times 4 times 4 is 64. And then the highest I would go is the cube root of 125. Because the cube root of 125 is 5. 5 times 5 times 5 is 25. So let's say if I want to factor this 27x cubed plus 64. Now this is a sum, and there's really no way around this, but these are the formats that we would be using. And for this particular question, because it's a sum, I'm using this one. Now in order to factor it, you have to follow this format here. Okay, and like I said, there's really no trick to it other than just following the format. What I do to remember this, in case you don't want to memorize it, is that your first factor is always just a plus or minus b, depending on which one you're doing. Since this is a sum, it's plus b. Then what I remember is that the next available sign is always the opposite, so minus, and the last sign is positive. Then it's double a, double b. So a squared minus ab plus b squared. Whereas where it's a cubed minus b cubed is a minus b times a squared plus ab plus b squared. So what I'm going to do now is factor this. So this is what I do. I label everything. A cubed is 27x cubed, and b cubed is 64. What I need to put it into this format is I need to know what is A and what is B. For A, what we do is we have to cube root it. When we cube root 27, remember that that cube root is 3. And when you cube root x cubed, that radical with the exponent would cancel, so it would just be x. Then B cubed, if I cube root both sides, I would get that B is equal to the cube root of 64, which I said over here is 4. So now we're just going to put this in the correct format. So we're following this here using a and b. So when we factor, we end up with 3x plus 4 times a squared. Now a squared is all of 3x squared. So you have to apply the exponent to both the 3 and the x, which would be 9x squared minus ab, so that's a times b, 3x times 4 is 12x, plus b squared, which is 16. After that, there's really nothing else you can do. So this would be in factored form. Now for 8x cubed minus 1. So this is a cubed and this is b cubed. So I would have to cube root both of these terms to figure out what is a and what is b. The cube root of 8, as I said before, is 2, and x cubed, the cube root of x cubed, the exponents would just cancel, so x. Now the cube root of 1 is just 1, because 1 times 1 times 1 is 1. 1 is a very easy number to square root or cube root or fourth root, because no matter what, 1 times itself an infinite number of times is just 1 anyway. So now we got to put it in this format. So this is the factored form. So we do a minus b, so 2x minus 1, times a squared. So a squared, remember, you have to square everything in that term. You apply the exponent to both the 2 and the x, so that's 4x squared plus a times b, so 2x times 1 is 2x, plus 1 squared, right, because for b squared, so 1. And this would be in factored form. Now we're going to, what are we doing? Now we're going to factor by grouping. This is the last method of factoring, which actually we do this when we do the AC method, so it should be fairly familiar. Whenever you have 4 terms, that means that you are going to have to factor by grouping. So I am going to group the first 2 together with the second 2 together. You look for the greatest common factor of both of those terms. X cubed minus x squared both have an x squared in common, leaving me with x minus 1. Since x minus 1 have nothing in common, that would just be plus 1. Remember, if there's nothing in common, just write a plus 1. And then we have the x minus 1. When you factor by grouping, as long as what you have inside the parentheses is the same, you know that you've done this right. So our factors are x minus 1, the one that's the same, and then what's left over, so x squared plus 1. And this is in factored form. With this last one here, same thing. We're going to factor by grouping. We have 4 terms. Both of these have an x squared in common, leaving me with x plus 2. And then these two, I can factor out a negative 3. The trick here is that whatever sign this is, you want to factor that sign out. So this is negative, so I'm factoring out negative 3, which leaves me with x, and then negative 6 divided by negative 3 is plus 2. So again, I have this that's the same, so that is one of my factors, and then this that's left over is my other factor. Now that we've learned all of these factoring techniques, we're going to put this all together and just do a series of problems. For this first one here, the first thing you should notice is you only have 2 terms. It is subtraction. 25 is a perfect square along with x squared, and 16 is a perfect squared along with y to the 4th. So this is a difference of squares. So remember how we factor this. We square root the first term, square root the second term. The square root of 25x squared is 5x. The square root of 16y to the 4th is 4y squared. Make 1 plus and 1 minus. See, you'll know it's a perfect square for these terms in terms of the variables and the exponents if the exponents are even numbers. And then in order to get the new exponent, what you can do as a little shortcut is you take that exponent and divide it by 2. See, 2 divided by 2 is that 1. 4 divided by 2, it's squared. So that would be the perfect square. If, let's say, for example, you had x to the 6, if you square root it, that would be x to the 3rd, because I just took the 6 and divided it by 2. So that's a little trick. Or you can draw it out, right? This means we have 6 x's, and look how many groups we have. 3, which is why the exponent is 3. So that's just a little side example. For this next one, we have 3x squared minus x minus 10. For this question, because we have a 3 in front of the x squared that I cannot divide from every term, that means we have to use the AC method. So first we need what is A times C. 3 times negative 10 is negative 30. The two numbers that multiply to give me negative 30 but add to give me negative 1 would be negative 6 and 5. So remember, these numbers here represent b. So we're going to rewrite this quadratic now, but instead of negative x, I'm going to use these two numbers. So minus 6x plus 5x, and then the minus 10. And now 4 terms. So at this point, we're going to factor by grouping. So that's how you can recognize these different factoring techniques. Quadratic with a number in front, AC method. 4 terms, grouping. So I'm going to group these two together. 3x squared and 6x both have a 3x in common, leaving me with x minus 2. The 5x minus 10 both have a 5 in common, so I can factor out a 5, leaving me again with x minus 2. This is my first factor, and then the rest, 3x plus 5, is my other factor. Now here we have 2x to the fourth minus 16x. So every time I'm working with any polynomial, the first thing I like to do is check to see if we can factor out the GCF, the greatest common factor. Both of these have a 2x in common. And when I factor out a 2x, I'm left with x cubed minus 8. X cubed, so whenever you have an exponent that is divisible by 3, that means that it's a perfect cube. And 8 is a perfect cube. So we're going to have to factor this. And just so you remember, the format for a difference of cubes is a minus b, a squared, plus ab plus b squared. So first I need a, which if I cube root the first term, that's just x. And if I cube root the second term, which is 8, that's 2. So now we're going to put it in this format. Don't forget that we have that 2x already on the outside. A minus b is x minus 2. Then we have a squared, so x squared, plus a times b, so x times 2 is 2x, plus b squared, so 4. And this is now completely factored. Last question here, we have 4x to the fifth minus 40x to the fourth plus 84x to the third. Again, I'm going to scan everything and first check to see if I can factor out the GCF, which all of these factors are divisible by 4. And then in terms of the x's, I can take out an x to the third. So I always look at all of the x's, and you can always take out the least amount that is present. So since the least amount is x to the third, that's what I take out. So now 4 divided by 4 is just 1, and I already have 3 x's outside, so we're left with x squared, minus 40 divided by 4 is 10. I have 1x left, plus 84 divided by 4, which is 21, and I already took out the x cubed. What we have in here is just a regular quadratic, which we can factor by trying to find the two numbers that multiply to give us 21 and add to give us negative 10. And those two numbers would be negative 7 and negative 3. So that means that my factors are x minus 7 and x minus 3. So that's all of the factoring techniques for factoring polynomials, including difference of squares, difference in sum of cubes, factoring by grouping, etc., etc.